Today on AI Actually, Kimi, shadow AI, and machine learning versus LLMs, prompt versus context engineering, and local models.
In an agentic world, it needs to be clear cut as to who the heck owns this, the success and the outcomes, and you can't sort of hide behind the agent.
We've gotten to this place where enterprise IT is not moving at the same pace as technology is advancing.
You can't wring your hands forever. You've just got to try stuff.
Hey gang, welcome to AI Actually. This is our fourth episode. I can't believe this much time and success have passed by. If you're a regular viewer, now onto your fourth episode, you're probably noticing I'm not Pete Riley sitting in the moderator chair today. I continue to be Jim Johnson, although I've been here for the others, and I lead Answer Rocket Consulting. You're probably also astutely noting that we have some guests today. We're changing the lineup a little bit. AI Actually, this is where we talk about AI in business and what's relevant. I think you know that if you've been following along. I do want to introduce our team again to the crew. Of course, Mike Finley's always here. Mike is CTO of Stellar IQ. But we have some guests today. Andy Sweet is the leader of Answer Rocket's advanced models practice. And I like to call him the only data scientist in the world that you'd like to have a beer with. If you've met enough data scientists, you get that. Shanti is a senior data scientist from Andy's team. And, Shanti's sort of the mad scientist in the basement running more models.
He's the real secret weapon. Let's Jim, let's just be real. Shanti is the real secret weapon. The rest of us are just mouthpieces, okay?
Guys, go ahead and introduce yourselves.
My name is Andy Sweet. Like Jim said, I lead our advanced models practice. What that practically means is we spend most of our time with clients helping them implement AI solutions that transform their business. And I think we've actually talked about this on a previous podcast. You know, a lot of mid-cap, large clients, ranges across industries, across different sizes. So look forward to the conversation today. And pass it over to Shanti.
Yeah, so Shanti Greene, I lead data science and AI innovation, which means that I get to play with all of the cool toys. If there is something new that's happened, like Kimi was released today, my job is to think about it and go, should we be using that? How good is it? How much is the improvement over last time? And is this even going to be useful for our clients, for ourselves? Where do we want to bring this in? So I get to play with all of the interesting technology and figure out what's real and what's AI actually.
And that's a busy job these days.
So fast.
The next release of Kimi from Moonshot or the CCP, whichever it is, I'm not sure, should we care? I don't know, and maybe we're all a little bit immune to sort of the next model release, especially one out of China. I watched the stock market today. It didn't move the needle either way. Shanti, what do you think of, do we care, the next release of Kimi?
I haven't used it yet other than like a quick one-liner to generate some code. But from the previous K2 release, it's fast. It writes approximately as well as like Claude 4 Sonnet, somewhere between Sonnet and Opus. Not quite as good as Opus, but it's good. It is a very good model. It'll generate lots of extra code, just like Opus does, which is if you want things that are object-oriented and put in different places. I think it's too much sometimes, but this new release should be faster. I think 60 tokens per second or so, 256K context window.
That's the vibe. The vibe out there is that it is a drop-in replacement for some of the proprietary foundation models that you can only reach, through OpenAI and Anthropic and others, right? You can just take advantage of Kimi. And as Shanti was saying, it does some of the same silly things and also some of the same really good things that those do. But the key is it's faster and a fraction of the cost, right? So it's just a reality that we have to integrate into our thought process. Everybody needs to move their SDLC over to being an AI augmented software development lifecycle. The question is, which models are they going to use and how much can they afford to pay for it, right?
Yeah, is there a world, though, where you sit in a client meeting and authentically say, hey, use Kimi from Moonshot in China?
Yeah, because we're going to run it locally. Like we're not sending any
Yeah.
data over to their servers. I've got all of the weights downloaded. Now, this is a giant model. So I actually can't run it locally well at its full size. I think it's 1.4 terabytes or something like that.
Mhm.
It's probably close to a trillion parameters. So it's big. And you're not going to necessarily run it locally on commodity hardware, but you get like 8 H100 GPUs. You can put that
Right.
thing out there and be
Yeah.
just fine.
You just
But
got
small
those laying
cluster.
around, you can do it. So Jim, think about it like this. Think about it like we're not asking people to double click on an email, right?
Yeah.
That to open a link that's going to go run some rogue code. These models, they're just a long list of floating point numbers. They're think of them as a spreadsheet, right? There is no evil floating point number. It's not like the ones below 0.02 are good and the ones above that are bad, right? These are just weights. Weights are just values that get multiplied. So if you have control over the code that uses the model, you never give the model the instruction pointer, right? You never get the power to go run something that it decides, then there's no reason not to use one of these models.
Yeah, and Mike, I just want to kind of build on that point. It's interesting you make that, and I think that's one of the areas that we see more and more with our clients, that they don't really realize what large language models are under the covers.
Well,
And when you kind of start to explain, look, it's just software, and you have these weights, and here's what it is. That it kind of demystifies, because you're right. But it is an area where really trying to understanding that is critically important. And so,
yeah, and if we throw this back to all of 2 weeks ago or so with the GPT-5 release, when they're like, okay, we're
yeah,
going to deprecate everything else. So if you're hitting this endpoint, you're going to get 5 now. Well,
Yeah.
I mean, I like 5 more than 4.0. I was never a huge 4.0 fan, but there were people who were, and they're like, but I built around that. I know
Mhm.
how that one performs. I like the way it responds back to me. Well,
Yep.
OpenAI is fully in charge of what's coming out of those models.
That's
So
right.
you lose that control and you lose the upgrade cycle if you upgrade on their pace. If you
And in
control the
this
weights, you control the model.
in this really high value audio world where the models are interacting in real time
Mhm.
with audio, and that replaces human time, one for one.
Yeah.
Those models, it's even more important that you have control over it.
Mhm.
And they did the same thing recently. They went from the O4 preview real time to the GPT real time release. Good news, it's released for the first time. It's not preview.
Mhm.
Bad news, it acts different. So
Yeah.
now imagine overnight, every one of your sales reps, every one of your support techs, every one of anybody that's customer facing acts differently than they did yesterday. I don't care if it's better or worse. I don't want it to change.
We have a packed agenda. The Kimi in the news unlocked a lot
Yeah.
of opinions here. One more thing that I wanted to sort of pick up on that's been in the news a lot lately is this idea of shadow AI and sort of what it is, and should we care about it? Should we shut it down? What's the, Mike, once you pick up on that one and define it for
Yeah,
folks and
sure.
give a point of view
So
on it.
shadow AI, right? So we all have AI in our private lives. There's no way of avoiding it. It's in everything you do online. It's you don't Google anymore. When you Google, you get answers coming from an AI. So now I go to work, and if work doesn't have that, if it doesn't have that capability, well, I'm just going to rely on my personal channels to get that done. So I might be doing a work search, but I'm going to go do it on my own offline from my work channels. I'm going to basically I'm going to countermand some of my enterprise requirements because I just can't live without these AI tools, right? And that creates this shadow AI setup. It can be as innocent as I'm just going to Google from my phone on a device that's not attached, and maybe I just by asking the right question, I'm giving away some information. Or it could be as bad as, well, I'm just going to dump this spreadsheet from work into a prompt or into a
Which I've
playground.
seen a
Exactly right.
proprietary.
just
Yeah. Yeah.
a quick
CEOs are
example.
notorious for it.
Yeah, a quick example. This week, a client we were at, they're trying to navigate this exact topic, but in the meantime, a senior executive was dumping architectural diagrams into GPT and asking for specs coming back for. So it's happening, and in the meantime, that executive's asking the IT department to come up with standards around this whole question of local versus flagship models and how it's run. In the meantime, they're dumping architectural diagrams into GPT.
When you
Yeah.
think about why they do it, it's because we've gotten to this place where enterprise IT is not moving at the same pace as technology is advancing.
Exactly.
They're so concerned with security and what's next and the principle of least privilege and what goes out that they're not thinking about, well, people are using it already. Let's give them something with a few guardrails around it that they actually want to use. And that's
Yeah,
what needs to change.
to paraphrase an old story about physics, DevOps changes one funeral at a time, right? I mean, it's just the reality of it.
Mm,
So until those modern AI oriented DevOps folks start, and I'm not talking about age, and I'm not talking about experience level.
yeah.
I'm talking about what they're willing to do. And by the way, this is not just DevOps; it's across any function out there. But until we are ready to sort of open up and let people work, like personal story, I was working in an organization building a suite of iPhone apps. We were acquired by a larger organization that said Macintosh computers are not allowed on our network, right? And the only way to build
Yeah.
iPhone apps is on a Macintosh computer, right? So, and it was the unstoppable wall and the unstoppable cannonball and the unbreakable wall or something like that. And so I left that organization and they were high and dry and missed the whole iPhone wave because of that stubbornness that they had. So we've got to move forward and turn shadow IT into something that's endorsed by the enterprise, because you get the right keys and you get the right secure access for people to use it properly.
So if you were going to get really specific, you're sitting in a meeting, this comes up, what do you tell them to do tomorrow? And I think it's going to be somewhat policy driven and somewhat enablement driven, because I do think you want your team members experimenting individually and bringing ideas to the table and growing their skills. But you do need to respect the fact that not just IT, legal, executive management is worried about exposure. There's a number of constituencies. But what would you tell them tomorrow to think about or take action on?
Two things: technology and policy, right? It's always, I was on an ANSI standard committee, and we always opened with that. The opening moment is, hey, we are here to establish technology and policy. The two work together. So the technology is, go sign up with one of the vendors. I don't care who it is. Go sign up with somebody that will give you a cloud-based access to a model so that all your employees can log in securely. They can get API keys. They can get what's called playground access, and they can get a chat prompt. So sign up and get that. That's technology. Policy is, you got to train people to only use that, and you have to train them on how to use that, right? And those two things in a matter of days can get you switched over. Personal story: my son, grad school at University of South Carolina, he was given his GPT access as soon as GPT-5 was released. They did a deal with the university. He got his keys, he got his login, and he's up and running in that environment. No longer shadow IT, right? Embraced. Very straightforward.
Awesome. Good advice. Okay. So that was sort of the in the news. Let's actually shift a lot of meat on that. Let's shift to a couple of other topics. And I know one of them is just helping our clients understand what is AI. I think for many, it's sort of exclusively confined to generative AI. They've started to play with GPT. Maybe they're doing some proofs of concepts, but there's a lot of focus on generative AI. But there's a whole world of AI that sort of stair-stepped us to this point. The things that came out of the data science arena, machine learning, et cetera. And those are still going on out there. And I think it's an important topic to think about how they coexist and complement one another.
It's interesting. This is there's kind of two fronts to this. One is, if you ask people about tool calling or function calling, oftentimes they don't know what it is, right? And so this idea of LLMs being able to go outside of themselves and make calls to discrete pieces of code, whether it be a machine learning model, it might be SQL, whatever the case may be, is a very, very powerful concept. And so a question we all get, Mike, Shanti, and I all the time is, okay, we have all these machine learning models. Do we replace all of those? And the reality is, no, you don't. You can actually leverage those. And it's a huge opportunity for organizations to really augment what they're doing from a data science perspective, because we've suffered with this problem of, how do we get our models and the output from our models to decision makers at the right time in the right place where they can actually make decisions that change the business? Well, there's no better way than through a large language model where I can talk to it, interrogate it, we can tell a funny story if we have time. It was interesting. So we did some work with Travel Centers of America. And one of the questions, and we did some diesel pricing, right? So if you go buy diesel, little trivia fact, if you go buy diesel today from Travel Centers of America, that's all priced by algorithms Shanti and I and the team put together. Now, you can't blame us if the prices are going up, because it's based on competitor pricing, and inventory. But, one of the questions the team's always had is, why is this price $356 in Louisville? What's causing that? Well, it's because Love's down the street just dropped their price to $360, and they didn't have that capability. But that's very powerful to have that explainability with models. And so love this topic. And then this is a point Mike always makes, I'll turn it over to him, is then you start to combine it with dark data that AI naturally does really well. And you start to have this power of bringing this data together.
Yeah, that's a great point, Andy. And the way that I think of this broad topic is to say, okay, all of this is machine learning. Anything that we've done since with neural networks and other algorithms like that, it is machine learning. Now, the latest incarnation is large language models. Well, what's a large language model? It's just a machine learning algorithm that was trained on a large amount of language, right? Easy enough. It's right there in the name, as it says on the tin, right? So is a large language model going to be good at predicting whether your customer is going to churn or not? And the answer is no, because it's a language model. It'll have an opinion about that because the language always has opinions, but it will not be good at predicting that thing. So if you have an algorithm that helps you decide where your next marketing dollar goes, does it go to this customer who may churn or that customer who may churn? A large language model is not the tool to ask, right? You ask your machine learning model that learned to predict which customers are going to churn, and then to make it, and those models are typically hard to use, right? There are lots of parameters and you have to have a data scientist use them. So you wrap that in a large language model that lets you easily take advantage of that tool. Hey, we've got $10, where should we spend it? Instead of, which subsystem do I integrate to the direction of the database? You just say, hey, where should I spend my next $10? And that's the 1-2 punch that's really working here. Enterprises understood this when they saw how dark data turned on and got really useful with the RAG techniques and language models. Then they started saying, well, hey, can I access databases, right? And we're getting a lot more of that. MCP brought some of that, and some text-to-SQL brought some of that, but really tool calling is what's actually made that work. Now, this third stage is saying, okay, how can we use our old, not necessarily old, how can we use techniques that were built before large language models?
No, we see that too, by the way, Mike. Yeah. It's
traditional.
Traditional, like machine
Classic.
learning's been around for 100 years, right?
Yeah. Absolutely. Yeah. So we tend to suffer from that. But anyway, these things end up complementing each other, right? To build out the whole. And that's the message that, that enterprises are hearing. For a while they're trying to hit everything with the RAG hammer, because it seemed like that worked really well in 2023. So why not try it, on other things? Then MCP comes along and they go, oh, I can actually use things that aren't RAG. Good news. We can do some other stuff there. This area of using machine learning models, this is what's next.
Yeah. And what's interesting about that, just really quick, is, more and more we're getting questions like, how can we have AI actually improve the employee experience? Like, take the drudgery out of work versus just doing, like, writing the marketing material for me. How could it actually go do work on my behalf? And again, we're seeing that especially in the real estate industry with underwriting. How can you take the drudgery out of land acquisition and underwriting and allow humans to do what they do best, create relationships with sellers of land, et cetera, right? And so it's almost like this flip. It reminds me of a story. We took my oldest daughter to Vienna and Budapest. And so I did what everybody does as a good dad. I went to GPT and said, what's a good itinerary for Vienna and Budapest, right? And it did all the fun stuff. It said, go here, do this, visit, blah, blah. And it was awesome. But who had the hard work? Me. I had to figure out what trains to take, where to be. And so it feels like that's flipped on its head, right? The AI should be booking my train, doing the work for me, and I can focus on doing the cool stuff and figuring out where to take my family. So I think that analogy applies, and more our clients are asking us those kinds of questions.
We're getting a little bit closer. A bunch of the new generation of browsers, so like the Dias, the Felus, the Comets, have some of that spatial reasoning where they can go and click the things and complete the purchase for you. So they can do some of it. Now, they're not doing it great yet, but it changes every day. So maybe tomorrow it'll be just what we need. It's getting pretty good.
Hey,
Well, and
circling back on this idea of sort of machine learning and large language models, I sat in a meeting with several senior executives from a very large, well-known fashion retailer, and the sort of general view of AI there was, hey, let's just give it all of our data, and it's going to. And Andy, I know you were part of this discussion, Shanti as well. Let's give it all of our data, and it's going to figure out how to think about segmenting our customers and sort of the value life cycle of a customer. That it never was going to do that, but I think this is an example of where sort of there's the intersection of the possibilities of machine learning, classic. Sorry, I used that word again. Classic models and large language models. Maybe comment on that one a little bit, because I don't know that we actually ever got over the hump in that discussion, but it sort of stalled us out what their expectations were.
Yeah. And again, part of the challenge too is we talk about this all the time, is large language models are getting better and better and better. So they're encroaching on things they couldn't do well just a year ago or 2 years ago. So that also comes into this discussion. We can say, okay, well, large language models don't do this well today. Machine learning models do this really, really well, but that's a shifting landscape. So that's part of it. But I think what can happen, and it may be in this particular case, is you start to fall into getting obsessed with the shiny object solution versus obsessing on the problem and really understanding the problem and saying, okay, what is the best solution for this? And really starting there. And it's very easy with everything going on in the market to go, wow, all we got to do is throw this into GPT-5, ask it a few questions. It's going to understand our context. And we all know that's not the case. And it can do these predictive kinds of modeling. We know that not always the case. So I think the key is, as you're implementing on your side, really understand the strengths of these different models before you start to implement, and then take an inventory of what you have.
Yeah.
You may already have things in your environment that you can take advantage of. And now the LLM just becomes an enhancer. It unlocks the value of those investments.
Well, in that example, there was a gentleman sitting in the room, another guy who sort of led the data science side, who, in essence, metaphorically raised his hand and talked about all of the models they've been working on that specifically addressed the questions that they were hoping that they could get a large language model to address.
Yep.
Yeah.
Well, we did work for a financial services firm, and we were coming in, we're ready to talk about customer lifetime value and segmentation. And as we're prepping for it, they give us some material to look at. Well, they had a customer lifetime value model that their statisticians had built, and it was good. I looked at the features in there. It's just how you would want to build this kind of thing. Been sitting on a shelf for 2 years. Nobody ever considered implementing it, even though they had it. They're like, well, I guess we're not going to try to sell them that. We know it won't go well. We should sell them some change management and be like, hey, if you build something, this is how you actually involve it and use it in your day-to-day.
Yeah, I was working with a financial institution, and they had built a fraud model, and it was brilliant. It was at least 5 percentage points better than anything they'd ever built. It was 500 basis points in their terminology, and and it was so cool that they gave the big demo, and this guy hunched over a screen, and it was black with green writing, and he typed a bunch of dashes and slashes and escapes and pressed enter, and it said 92, and they cheered, and all the executives were like, okay, when's lunch? They just completely missed each other, right? And so this is that magical part about unlocking that algorithm. Might have been beautiful, but if very few people can use it, then it's going to go nowhere. And look, so let me make a generalization here. See what you guys think of this. Large language models cannot do most anything that humans cannot do. In other words, they're basically trained on all the things that humans have done, and they're able to do those things faster and repeatably, and across a broader range of subjects. But they're not doing many things that humans can't do on their own. Now, an example of something humans can't do on their own is figure out the right way to, out of these 50,000 features, how to classify which of your customers are going to churn or not, right? We built these ML models that are superhuman in their capabilities, right? Superhuman means that they beat 98% of humans at doing a task, So these machine learning models can do that. The LLMs are not built to do that. They're built to do what people can do, only faster, right?
Yep.
So that's why these machine learning models will continue to persist, and in fact they'll get better. Now over time, language models will build their own ML models, right?
Absolutely.
And that will become how they operate. They'll build their own little neural networks to do these little side jobs. And in fact, there is evidence, if you look inside the brain of the LLMs today, there is evidence that they are already doing that inside their little brains. They're building algorithms for how to add numbers, how to do some basic things. You can see the little neural circuits going on inside. So they're already doing it to some extent, but they're not certainly doing it at the scale that Shanti is talking about, where you're doing a lifetime value calculation that's based off of figuring out what the features are and tracking the drift of it over time and locking into a specific way of using that algorithm, right? So it's continuing. In the language model world, we got to continue to respect our documents. We can't count on what the model was trained on to begin with. You have to bring in documents. You've got to bring in your own data. The model was not trained on that. You've got to bring in your algorithms because, again, the model wasn't trained around those. And you have to continue to respect the code that you've built, right? That's going to be valuable. And integrating all that is how you use AI to take it a step further.
Yeah, no,
Mike, I think
I love it. So sorry. I call a machine learning model when they work really well, and of course ours work really well. Kind of goes with that, but they're like a magic 8 ball, right? That gives you the right answer, can predict the right answer. So you're asking it, what is a price? What is a lifetime value? You shake your magic 8 ball, and this is a more sophisticated one than I had when I was 8 years old. And it says, here's the customer lifetime value of this customer, and here's how so you're right. I love that way of describing it, Mike. I thought you were headed down a path of model collapse and what happens when we start training LLMs on content
that
that's
LLM
not
generate.
human generated, but it is LLM generated.
That's a different
topic
story
for the
altogether.
future. Mike, I think you just sort of hit into one of the other topics we wanted to talk about today, which is prompt engineering versus context engineering. And I think maybe start there. Let's talk about definitionally what it is. But then I think this matters enormously to success in AI-powered solutions in the marketplace.
So,
Tee it up.
in coming up 3 years ago now, when people first started using GPT, I remember, at first it was, "Hey, write me a song about pirates or whatever," and it was kind of fun. And then I started seeing people ask it questions like, "Well, what if this is the sales data? What's its sales going to be in the future?" Right? Already starting to ask questions, and then they would say, "Oh yeah, the problem is that I've got all these decimal precisions in the data that I'm giving it. Let me just round it for it, right? And then give it to it again, but rounded." Then people would do things like, set variable equals inside the context, moving where commas go, saying things to the LLM in a way that's like, you are a fancy analyst, right? That's prompt engineering, the original kind of prompt engineering that just says you can move around the commas and do things that you want and get a better answer out the other end. Context engineering is the evolution of prompt engineering. And context engineering says when you reach out to a language model to have it do a piece of work, it turns out you're not just giving it that text, right? It turns out you're also giving it a list of tools and some settings about the variability that you want to allow it to use, and some settings about the specific repeatability of certain words, and some settings about the context that it's working in, right? The ontology of the data that it can access, right? So that's what we call context engineering. The prompt engineering is kind of moving the commas around and changing the sentences. The context engineering includes prompt engineering, but it's got a whole lot more to it now that really turns this idea of making a language model call into an engineered entity rather than saying, "Yep, I'm just going to type something and press enter." Prompt engineering, this is now an enterprise value. I'm going to go spend 4 cents on this piece of work. Let me make sure it's right, and make sure that the answer comes back in a way that I can use it.
Yeah, something I would throw out there is that humans aren't very good at writing prompts, but LLMs are pretty good at writing prompts. So you honestly don't need to do prompt engineering anymore. What you do is you just start with your idea of what you think a prompt is and just ask the LLM, write me a better prompt for this. And it'll come up with a pretty good one, and it'll give itself the details it wants and just throw that thing right back in there. Sometimes I'll use different LLMs, one to write the prompt, a different one to actually execute upon it. And that works out quite well. On the context side, you really want to think about the problem you're trying to get an LLM to answer so that you can give it appropriate context so it knows how to even approach a solution to that. So if you're going to ask it to do something complicated, like write some code to solve a problem, well, what would you have to explain to a human who is going to do that same thing? What some of these things mean, how they interact with each other, what an acceptable range of solutions might look like, and how you want to see that put together. And then maybe it'll actually get you that answer. A couple of days ago, I was writing some SQL for something, and like 18 minutes into getting AI to do something, I was like just writing a prompt, and I was thinking about the problem and all of the logic for it. So I'm like 18 minutes into just writing the prompt, and it just hits me like I could have written this code in about 5 to 10 minutes. But I so far down the line, I'm like, well, I'm going to spend 2 more minutes and see if now that I've given it all of this information and exactly what I want the logical structure to be like, it'll get it right. And it was pretty darn close. So I was pretty happy with that. Still probably not the best use of time, but I do like seeing how far can the model go to like just one shot it. Like if I give it the right prompt, can I get this first try? The models are getting better with the right context. You can often get that.
Yeah, at that point, you were pot committed, as we
Yeah, pretty
say
much.
in poker.
Where does the idea, when we think about context and context engineering and prompt engineering, sort of a hot topic coming closely on the heels when we think about agentic AI, agents operating successfully in the business environment, the idea of memory? Because every time you sort of start the agent or the agent spins up to do something, there's this thought out there that it's sort of starting all over. And many of these problems, many of these business processes that you want to support in the business environment require some level of context or memory that exists over time. Any insights or reactions on that point?
Yeah. So look, the I like that Anthropic definition. An agent is just an LLM in a loop, right? You're calling it over and over. Try this out. Go to GPT, ask it whatever your normal question is. A recipe for fried chicken or something, and when it answers, just say okay and press enter. And whatever that comes back, just say okay again and press enter, right? And so now you're in a loop, right? You'll see that you get nonsense, you get not useful results when you do that. And so it's not just, an agent isn't just calling an LLM in a loop, right? An agent is actually changing what goes to the LLM each time through the loop based on what came back the previous time, right? And what is the thing that changes the prompt and the context from one agent call to the next? Well, that's code, right? So you have traditional code managing an LLM, and there's a prompt, and you're modifying the prompt. There are tools, you're evolving those tools. There's settings that belong to the language model. There's the context of the conversation, the turns, as they're called, from the user to the model. All of that, getting all that right is what we call the context. And what's really interesting here, Jim, is that the model providers are training their models, especially that last little bit of the training, which is reinforcement with human feedback. They're training it on specific ways for the model to work. So if you start asking questions in a way that falls away from those ways that the models have been trained, you get worse and worse results, and that's called context poisoning. So it's possible that you have a very well intended prompt that Shanti created using another model. You've got some tools that are very well intended. You pulled them in off the internet from 5 different sources that your kids came home from school talking about, and now you're calling the model in a loop, just like Anthropic said to do, and it doesn't work. It falls apart. It lies. It doesn't call tools for you. It gets confused about the task. It starts burping pieces of its own prompt back at you, right? Then that context poisoning is occurring because this context engineering is a serious problem. You do have to understand how the models themselves were created, how they were trained, and therefore how to compose your prompt in a way, your prompt and your tools and your context and your parameters and all those things, in a way that lines up with what that model is expecting, and that's how you get the value delivered from it.
Yeah, and this kind of goes to a topic. I don't know if we're going to hit this today, but just a little bit. It seems like organizations more and more are asking for AI literacy programs. How do these things work? And what is the art of the possible? And, starting with senior executives and getting them to understand the decisions and how they could potentially use models. But then working down, Mike, it goes directly to your point. How do these models actually work when you're giving it context, and how does it make tool or function calls? And is it in understanding that and investing the time to understand that, I think is critically important, and not treating these models as magical black boxes that are going to do great things on your behalf, but really start to dive under the covers and understand how they work. And so the clients that are really, really successful are doing exactly that. And or staying up on how the latest models actually work under the covers.
That idea of context engineering, I think, is effectively what we constantly refer to as the last mile, which is how can we bring this to life in a solution that's specifically designed to specifically do what is specifically needed for that client in that moment, ideally as an agent that is operating effectively in the enterprise. And
Securely, repeatably, at the lowest possible cost in the fastest possible way, right?
right, explainable, auditable,
Yeah.
you know what happened, you know why it happened. But that bringing that context to life is unique for each business. It's not a cookie cutter. So this idea of sort of taking a generic, a generic agent and using it from business to business to business, at some level that is a great starting point, but it's probably not where sort of differentiating value comes from. Differentiating value for that business is unique in terms of the context that they bring to the agent or that is brought to the agent.
And to bring this full circle to something Mike mentioned earlier, the reason you want stability in that model, and you want to know which model it is running behind the scenes and that those parameters aren't changing. So you spend all of the time figuring out how to provide context in that model's language, the way that model wants to hear it, and then understanding how it's going to give that back to you so you can integrate it with your other processes. And every time there's a model revision or change, those little things like what it does with the context and how it uses it can change a little bit. And that's where you get instability.
Well, two things about that. One, am I wrong that when they introduced GPT-5, they actually sort of took away 4?
That's what happened initially.
That is to me, that was a stunning lack of recognition by OpenAI about what enterprises were doing in the market with their tooling, to say, okay, we can take it away, and not recognize that would unsettle thousands or tens of thousands of workflows and agent flows that were going on out there in the business. It's sort of startling that could happen. And then I think you just sort of bled into another topic, which is near and dear to our hearts, which is the idea of agent ops. Yeah, you may not go from GPT-4 to GPT-5 powering your agent, or to the next Gemini, but there are things happening behind the scenes where the weights do get changed in a model if they find behavior they don't like, that could impact the performance of your solution. Sort of being able to keep up with that and proactively monitor the agent that's in place and sort of keep it doing, I like to do that, keep it doing what it's supposed to be doing within the guardrails. It's just an ongoing thing, and doing that effectively and proactively. There's 3 parties in the room now. There's the business, there's the agent that they've introduced. Maybe there's a service provider like Answer Rocket helping. That's great. But now somebody else ultimately potentially owns the brain, and they can make changes to that brain, and it can change the behavior. And that sort of agent ops are continuously sort of monitoring and tuning what's going on with it. It's a new thing. It's a new role. It requires some IT skills. It requires deep functional understanding of what you're trying to do. And it requires deep AI skills. And it's not just one guy sitting in a room sort of being the human in the loop.
That's right.
Into a rant there, but
go ahead, Mike. Yeah.
I was just going to make an analogy, right? So think of the LLM as provided by the people who made it, who trained it, spent billions of dollars in some cases. That's a really, really smart human, right? And then the agent that you want to hire is a Harvard MBA. So the inputs for a Harvard MBA is a really, really smart human, and then a hell of a lot of training and an assessment. A lot of assessments of is that, now imagine that Harvard MBA is on the job doing the job that they're supposed to do, and it turns out that they don't have any stats skills, right? Well, that's not acceptable. It's not possible, right? You have to be able to say every day, hit the big red test button, make sure that the model still remembers everything that it's supposed to know. Not as a smart human, which is the only thing that the model providers are guaranteeing, but as a Harvard MBA working in your business. And that's what the context is giving you, right? And so that accountability, nobody is going to guarantee that for you except for yourself. And so if your framework doesn't include the ability to regression test frequently, then you are going to be susceptible to the changes in the weights.
And I think with this hand thing he does, I think also part of that hand thing with that Harvard MBA is making sure the Harvard MBA doesn't pick up any bad habits as it operates within the environment and keeping it on task. So just like if you were to bring in, I love that analogy, bring in a human, right? You would monitor their progress through the organization. And so treating it the same way, I mean, it's in some ways what I'm saying is simplistic, but that is kind of the mental model that you potentially use.
Well, and I just
this
enjoy
is me
pushing.
keeping it on track, by the way.
Yeah,
Sorry.
that's what it was. Yeah.
I'm just going to push this analogy a little further because it's fun and I've got opinions, which is, okay, so say your Harvard MBA decides we're just going to fire your whole work staff because that'll cut costs and your revenue, then you'll have better margins. So how do you decide that you don't want that to happen again in the future? Well, you could get rid of that one Harvard MBA, but he still had the same training as the previous one. So the next time you bring one in, they'll do the same thing. Or you go and talk to the Harvard Business School and be like, hey, you've been training these people to do this thing. So they change their training. You get a new one in, you drop him in the same role, but now he's doing something different than the previous one was because we've upgraded the version.
So just to hop on, we are going to beat this analogy because I love this. Like, so imagine hiring a Harvard MBA, and this is how models work and agents work today, and there's no ramifications for making poor decisions, right? They're almost like a trust fund Harvard MBA that they make things wrong, and as a human, you suffer some consequences, right? You may be put on, whatever, probation or whatever the case may be. There's consequences to bad decisions. There's no consequences to a bad decision like an agent, this Harvard MBA, making a poor decision.
Ultimately, this is why somebody has to own it. There is no world where there's nobody in an organization today who ultimately doesn't report to somebody else, and they have some level of the individual has responsibility and their boss has some responsibility. In an agentic world, it needs to be clear cut as to who the heck owns this, the success and the outcomes, and you can't sort of hide behind the agent.
So yeah, what I heard you say is anytime I screw up, Jim, it's your fault.
So I got a funny story here that I'll tie in. So I was working at Vanderbilt in the physics department. They were studying. We were studying why the tail of the space shuttle. So I'm dated because of that. Why the tail of the space shuttle would glow green, right? That green is oxygen, but how is oxygen leaving the tail of the space shuttle in space? So long story short, we're in the lab and there's all this high vacuum equipment and there's 20 different scientists in there and everybody's focused and all of a sudden something smokes, right? And everybody like, oh my God, what just happened? The experiment, every minute counts. 19 engineers, 19 PhDs ran over to a whiteboard and started drawing circuits and debating with each other. And one mad scientist over in the corner kept soldering and turning the switch and pop, and solder and turn the switch and pop. And the scientists over here, at some point they exclaim, oh, it's the Xena diode, right? And in the meantime, the other guy's like, zzz, pop, right? Within 8 or 9 minutes, the one guy in the corner went over to the other guys and said, hey guys, it's working. And they all turned around and said, how could it possibly work? We haven't told you the value to use yet. And he said, look, we only had 20 possible values to try, and it was number 6. Right. So this is what we in the AI world, this is what we call the scruffy approach to AI. Right. It means that, you don't have an infinite number of possibilities. You can't wrangle. You can't wring your hands forever. You've just got to try stuff. And without that one guy that you're talking about or gal that you're talking about, Jim, that's in charge of this, you're never going to be able to make those quick decisions to move forward. It's so critical and so important to have that one person that's accountable, that understands, that takes responsibility and reacts quickly to stay current with all this stuff that's going on, to keep the Xena diode dialogue out of the picture and make the thing actually come up and work.
So I just have to ask, Mike, were you on the whiteboard or were you the mad scientist with the soldering?
I was getting the smoothies. This was solid days.
All right. So you know what? I do want to jump to we've brushed up against it multiple times. We kicked off with it a little bit about the idea of local open source models, where it makes sense, where it doesn't, because it certainly addresses some of what we talked about earlier, which is somebody coming in and changing the weights of the model, or some other update that we were unaware of until our, enterprise AI powered solution starts wandering off the rails and we don't know why, and we have to figure out what OpenAI or the folks at Google did. So, Shanti, I'll let you pick this one up. We have clients who are super early in their journey who are looking at the possibility of let's run the model, let's own it, let's have it locally. Heaven forbid they actually try and train their own model, but let's run the model locally because that's going to solve, maybe issues around compliance or issues around, personally identifiable information that we're worried about leaking out. There's a lot of reasons, both technology-wise and business-wise. So let me kick it to you on that.
Yeah, there's some good reasons that you might want to run a model on your own. We'll figure out whether that's locally in your data center in somebody else's cloud where you're renting GPUs, which is probably the best way to do it if you're going down this route, or you're just willing to take like a private US provider that has an open weights model, because that way at least okay, these are stable weights. So there's a few different ways of implementing it, but you've got to do it for the right reason. And the right reason is not cost, because it seems like it's going to be cheap, but that's just because the costs are different. You're going to need people, and finding that expertise is a lot harder than people think it is. And then you need actual hardware and equipment that does not come cheap or is difficult to acquire in the first place. I can't get H100s even if I want to own them myself. I could maybe get like an 800, but that's about as good as it's going to go. And the higher
I'll
number
be
is not
watching
better.
your expense report. Sorry, keep going.
Yeah, exactly. That's why there was that cluster that you needed. So there's just different costs, and you need a lot of hardware in order to run a large model. Where it starts to make sense is if you have simple tasks like, oh, I need to constantly summarize documents. I can do that with a very small model. Now I can run that on commodity hardware. I can run that on a laptop. I can run that on a single GPU. So if you've got small tasks and you're worried about privacy, great, 100% run that kind of thing locally. But if you think like, oh, we're going to save money, we are worried about our Claude bill because that thing explodes through the API, you're just shifting that cost in a different direction. There's also a time cost. Like, it's not going to be quite as good, and it's going to take you longer to get things stood up. And if you ever want to upgrade it, then you have to go through a whole process. So things are just different. They're a little more challenging from a technical standpoint. So do it because you have some specific use cases around like proprietary data that you really can't let anywhere else, because all of your providers would say, hey, if you give us money, we'll put you in your own walled garden there. We won't train on your data. And if you believe them, because at some point we have to believe that they're going to do that, then you should probably just go down that route. It's going to be easier. You'll get out of the gate faster. All your POCs should be done that way. But if you're like, this is super special, we 100% want to control it, and we need to build around it, so we want it to be stable, you can do it. And
I mean, what's interesting is a lot of the actual ROI delivering AI solutions out there today are pretty simple.
Yeah.
They are sort of part of a workflow or a decision point in a workflow, or let's take this documentation that we get on a regular basis. Maybe it's about, millions of invoices from vendors, and we can turn that into structured data that then we can sort of run the rest of the process from. They are not sort of deep learning, deep thinking kinds of things where you see the actual real dollar value coming in.
Yeah, you might even have a like larger, fancier proprietary model be your controller over a group of small agents where each agent is small and you run those locally, and it just feeds back some sort of result that you're okay with it giving, like a decision that was made but not having the actual data or data access. And you could build your agentic system that way with lots of little models, because those are easy to run locally. You can have control over them. You can fine tune them. Also, like, while you can fine tune large models, it's not worth your time.
Yeah, I was going to, even the fine tuning, for someone who's not sort of way up the curve, that one makes me nervous. Sorry, Andy, you were going to chime in there.
No. I one of the interesting things about being old, like me, is you hear some of these debates. They're different flavors, but it's over and over. And in a lot of ways, it almost feels like the cloud adoption conversation, right? And there were great reasons to stay on-prem, but a lot of people were staying on-prem just because they were afraid, or they didn't understand, or they weren't able to really take in what the pros and cons are. So I think we're going to maybe go through that same, and maybe I'm simplifying it, Mike, you can disagree with me here, but I think that's kind of where we're at. And I think it might follow a similar curve.
I think so.
Around adoption.
Yep.
Yeah, look, I think Shanti hit it on the head when he said, do your POCs without setting up your own hardware, right? Figure out if the agent's even a good idea for this task. What are you going to ask it to do? What's it capable of? And then once you have it, kind of in a state that you would call it a prototype, it's a working application, but it's using LLMs that you don't own, that aren't physically in your control. And now you want to scale it, or you want to privatize it, or you want to make it more dependable, all those things, then move it into your data center and take that action. But until then, it's kind of a fool's errand, because you may end up buying the wrong chips or the wrong quantity of chips or the wrong arrangement of them. You may end up committing to hosting time and space that you don't need because there's another generation of hardware. All sorts of things. New options come online that weren't available when you were making your initial commitment. So yeah, it's just a better idea to work with the smallest possible commitment until you have a working machine. Yeah, and then scale it up.
Yeah.
Using the hardware.
With the cost of inference continuing to sort of plummet on an apples for apples basis, it just feels sort of taking on that level of sort of figuring out a whole bunch of other variables now, to Mike, to your point, sort of you just listed 3 or 4 or 5, feels like a tough road to follow to recommend right now. It feels like it's easier to say, okay, I'm just going to default to the flagship model and rely continuously. 6 months from now, it's going to be that much cheaper. Rolling my own. The one other thing I would say about this, and this may be sort of the inverse argument of what I was about to say, I think there are a lot of people who, once they finally leaned into the cloud, to your point, Andy, felt like they got surprised by the cost and were caught off guard by that's why you see so many larger enterprises are sort of, hey, we're dual cloud. They want to at least sort of keep or multi-cloud. They want to at least sort of keep the competition going, but they felt surprised by the cost. And I've heard that in discussions. There's clients right now who are sort of afraid of what the underlying consumption bill is going to be, and they don't want to be in a fool me twice type scenario. So it's out there. I don't know where it's all going to land.
They should be afraid of the cost, because if you ever price out enterprise software, it starts in like that $100,000 range, because it's a large company buying it. They can afford this, not because of like, oh, that's what the costs were. They did some pricing analysis with some fancy models. They went like, take a swag, let's see where we can go with pricing. But when you think about your data costs and all of the software around moving data and data quality, they're all individual solutions for doing these different things. Those costs add up really quickly. So AI can be another one of those huge costs. Like, you enable your entire organization, and if it's like through the API, which tends to be one of the more expensive ways to get people access, you better watch that cloud bill. I ran up an $83 Claude API bill in 90 minutes. Unfortunately, on my own personal instance of it, and not the covered instance.
Thank you for that.
Yeah. But I also have a really cool plugin that will show you like how much the different calls you've made are costing you, and it's really fun to watch. I'm like, ooh, I hope this stops soon.
Right. Yeah, it's really interesting that some of the billing plans for, and I assume that was code generation activity you were doing, Shanti. Yeah, so Claude, as an example, has the ability to just pay a fixed fee of $150 a month, and then you can use an unlimited amount of that resource, or you can pay by the drink if you're using less than that amount per month. And so there's some flexibility there, but $150 per developer is not a trivial amount. I was looking earlier today. I use Cursor as and Claude Code, but I use Cursor backed up by OpenAI as my IDE. It turns out Cursor is counting how many times I've accepted code that the LLM proposed. I didn't know it was even doing this, but it turns out more than 100 times a day I am accepting code that the model presented me with. I had no idea it was that many. It's thousands a month, right? And I don't even code full time. And so the amount of productivity that I'm getting out of that money is really staggering, and will continue to be impressive. Now, something else that's interesting that's happened very recently is I've started looking at audio tokens. So not text tokens, but audio tokens. Now, and when the AI is taking in audio and responding in audio, so it's speech and speech both ways, it's basically replacing human time 1-to-1, right? Because a human would have had to speak, and the model's gonna do that speaking instead. So it's 1-to-1 replacing human time. So what you find is that the costs for these tokens are through the roof compared to the cost for text. And that's because the model providers are leaning into this idea that, hey, this is valuable, right? They don't want that kind of 1,000-to-1 value that we're getting, I think is about right. So in theory, that $83 bill, Shanti, was worth 83,000. I'm not sure if that math works.
They're going to have to make money eventually. There's some point out in the future where these curves have to cross.
Yeah. Yeah, and so it is curious to see with these audio models. I think that's what's going to push people to deploy in their own clouds, is basically getting open audio models that replace that one-to-one human time, because these tokens are so expensive, and kind of push the large foundries into the mode of reasoning and other higher order tasks rather than being in the speaking task space, which seems to be something they're good at right now, but expensive.
Hey guys, unbelievably, an hour has passed. I still have more topics on the list. I know, it's disappointed. This has been a fantastic conversation. I appreciate it. Shanti, Andy, thanks for joining. Clearly, you'll be joining again. Mike, as always, thank you so much. And for the team that pulled it all together here, thank you, Vivian and company. And we will see you all next week, hopefully, for episode number 5. Thanks all.